Hey now! Welcome back. If this is your first time, please consider subscribing or liking the video. It really helps. Thanks. Now that that's out of the way, what's going on, YouTube? Today we have, well, I don't really know. According to the instructions that came with this is, and I quote, Adjustable Flash LED White Flash LED Plug-in Circuit Kit, SMD Soldering Practice Kit. And that's it. Instructions are pretty vague. It gives you a list of components and the basic wiring diagram, and that's it. Well, besides this gem of the paragraph. Again, and I quote, They are great gifts prepared by parents for kids who are interested in. It is so amazing to share the DIY time and realize your great idea into reality with kids who just need to follow some easy tips to get this skill. Yeah. Wow. Look, I'm not here to knock the people who sell this product, but honestly, this lost in translation shit is getting out of hand. It's been going on since forever. When I was a kid, let's say in the late 1900s, this happened in video games all the time. We had such classics as, A winner is you, and I have no idea who you are, but thank you for arousing me. And the classic meme, all your base all belong to us. Classic. I mean, I can give the Japanese a little leeway. It was the 1980s, and video games were a niche market for the most part, and games back then were made by like 12 people. So translation mistakes were expected. But come on, man. It's 2024. There are literally earbuds that can translate dozens of languages on the fly. But here we are. I don't know, man. You're selling products to the West. Maybe, I don't know, at least hire... No, not even hire. I'm sure someone on the internet will do it for free. Or maybe hit up Fiverr and have someone write the instructions. Just saying. And what they're charging for these products, people won't complain about another buck. Rant over. I purchased this kit from Amazon because, well, where else are you going to buy stuff like this? Huh. Anybody remember Radio Shack? Put your best Radio Shack memories in the comments below. And press F to pay respects. This kits? Costs $29.99 and comes with 5 projects. It's sold by the Diodes store, which actually has a lot of good projects for learning to solder. Maybe I'll put a link in the description. Also, this video not sponsored by Diodes. But it could be. Shout out Diodes. Hire me to write your instructions. Well, that was fun. And now for the real fun. You know what time it is? It's time to make shit. Yeah? No? I'm sticking with it. You can't stop me. I'm going to try to do things a little different this time around. I'm actually going to try to explain, in layman's terms, exactly what I'm doing and what components I'm using. Now remember, I'm still new at this, and I may not know what everything does, so this is where my new friend ChatGTP will come in. Whatever I don't know, I'm sure he does. Does AI even have a gender? I'll just call it Pat. If you know, you know. Well, as always, let's set up our work area. I like to pull out everything I'm going to need beforehand and have it ready. And like I said in the past video, card to write, you do not need most of the things I am using. All you need is a soldering iron and some solder. With the Diodes, that is fun to say. With the Diodes kit, you can get started doing this for less than $100. Actually, I just looked it up. Soldering kit with everything you need, $13.99. Diodes kit, $29.99. So for roughly $50 with tax and shipping, you're in business. How long will the soldering iron last? Who cares? It's $14. It'll last long enough for you to figure out if you like soldering, and then if you want, you can go out and buy a good soldering iron. Like the TS-101 I have. Actually, is it a good one? I think it's a good one. But like I said, I have no idea. I'm new here. But it was in Pat's top 5, and Pat knows best. And with that, let's get to work. What I'm doing right now is called tinning the pads. I'm adding a little solder to the right pad. I'm a righty, so it will be easier to solder the component. By doing this, as you should be seeing right now, you just reheat the solder and push the component, in this case a resistor, more on that in a sec, into the melted pool of solder. Hold the component in place with some tweezers, remove your iron, and done. You should not be able to remove the component at this point. If you can, the solder didn't take to the component. Try adding a little flux and do it again. With these kits, I like to do all the same parts in a row, but you could do it any way you like. I find this cuts way down on confusion with maybe mixing up different resistors and other parts, but then again, whichever way you find more comfortable. Now, resistor. What's that, you say? Well, a resistor is a component in electronics that limits the flow of electrical current. You can think of it like closing down a water valve. Closing the valve down a certain amount slows down the flow of water a certain amount. As long as the inlet pressure on the valve is constant, closing it down a certain percentage will make the output decrease a measurable amount. So if you have 100 pounds of constant pressure on the valve inlet and you close the valve 10%, your output should be 90 pounds. While with a resistor, it's adding a specific resistance value, closing down of the valve, to the circuit. Take a light bulb, for instance. The resistor in the bulb, be it an old-style incandescent bulb or an LED, will absorb some of the current and give off its energy as light. In the case of the old-school incandescent bulbs, most of the energy was heat. This is why LED lights are much more efficient than incandescents. Incandescent bulb was only 5 to 10% light, and the rest of the energy, 90%, was wasted as heat energy. Conversely, LEDs convert around 80 to 90% of the energy they consume directly into light. That's why an LED bulb will use only roughly 15 watts to create the same amount as a 100-watt incandescent bulb. Resistors work on a scale called ohms. That's the horseshoe-looking thing you see in some electric diagrams. That's what that thing means. As for the numbers on the resistor, these are a code. It's a stupid code, but a code. Why they just can't write the rating down on the resistor, don't know. It is what it is. The code is easy to read at least. The three numbers, like the 113 or the 561 I'm installing here, the first two numbers you keep, and the third is the multiplier. So in stupid people like me terms, a 113, it's 11 with 3 zeros, so 11,000 ohms, or 11K. So the 560 resistor is 56 with 1 zero, so 560 ohms. I guess the code is easy enough, but whatever. I mean, even if it is, let's say, 555, which would be 55 with 5 zeros, 5,500,000, couldn't they just write 5.5 M ohm symbol? It's not like they don't have the space. You need a magnifying glass to read it anyway. But I'm not an electrical engineer, so what do I know? Let's not even get started on through-hole resistors with their color codes. I just use a multimeter and let it tell me what the resistance value is. It's so much easier than having to look up the code every single time. So getting back to what we're doing here. I flipped the board around so I can get to the other side of the component, righty and all. I have also been experimenting with going lefty. It's not too bad, it just takes some getting used to. For a bit when I first started, I would load the tip of the iron with a little solder and let capillary action pull the solder into the joint. I've since learned to feed the solder into the joint. It just seems to work better, especially when using this J-tip you see here. You'll see what I mean in the next video. Alright, let's finish up these last few joints and give the board a good cleaning with some isopropyl alcohol. All the joints look good, if I do say so myself, so let's move on to the next component. Capacitors. I really don't have a good analogy to explain what they do as of yet, so I'll let Pat explain it for me. Pat, take it away.
A capacitor is an electronic component that stores and releases electrical energy. It consists of two conductive plates separated by an insulating material called a dielectric. When voltage is applied, electric charge accumulates on the plates, creating an electric field. Capacitors are used in various applications such as filtering, energy storage, and signal processing because they can quickly release stored energy when needed. They are essential in circuits for stabilizing voltage and power flow.
Thanks, Pat. Informative as always. And of course, you would solder these components the same as any other component. Okay, let's move on to the integrated circuit chips, or IC chips. To install these in place, I like to tin a corner pin and place the chip, then solder the pat pin to hold the chip in place. With doing this, you won't have to worry too much about it moving around when soldering the rest of the pins. For the rest of the pins, I like the drag solder technique. To do this, just flux the remaining pins, load your tip up with solder, as the name of the technique suggests, drag the tip down the pins, and easy peasy. That is, until you get a solder bridge across the pins, as you can see here. This is easily fixable, as you can just try and pull the solder away from the bridge. Use as much flux as you need. Remember, flux is your friend. And keep pulling away. Most of the time this works, but sometimes, just sometimes, you may need to use solder wick. More on that in a later video. Considering that there are no real instructions for this thing, I have no idea of these chips' purpose. The datasheet says that the first one, the CD4060BM, is kind of a timer circuit, and considering that there are 8 LEDs on this board, and that I record this voiceover track after I finish the video, I can say that's exactly what it is. If you ever need to know what one of these things do, you can always search the ID numbers and look for a datasheet. The datasheet will give you a breakdown of what the chip does and a breakdown of what each pin is actually doing. Isn't the internet wonderful? It's so much more than negative comments and pictures from your mom's brunch. Next up, some diodes. Diodes are pretty easy to understand. They only let electricity flow in one direction. As it was explained to me as a youngster, they're basically a check valve. Usually they need a certain amount of voltage to open up and let it through. But again, no instructions with this kit, so it's hard to tell their purpose in this application. I'm starting to think most of the components in this kit are for show, but I guess this is just a practice kit and it's not meant to teach you how it works. It's just meant for you to hone your soldering skills. It's too bad really. They should incorporate a little bit more information into these kits. It would only be a few more sheets of paper and it would be quite a learning tool. Let's move on to some more capacitors. These are quite larger than the caps we installed before. They are also constructed quite differently. They have an electrolytic compound in them that helps them store more energy than their ceramic cousins. They also have plastic bases, making them a little bit more tricky to solder. Notice the tip change? You have to be a little more careful not to melt the base. These caps are also polarity sensitive, meaning you have to make sure that they are facing the right way, or they will literally pop when voltage is applied. Usually, the side with the stripe is the negative side, so pay attention. In this case, there is an outline on the PCB to show you how to install it. Just match it up. Not so much in this situation, but when working on circuits with much higher voltage, you have to remember that caps store energy. Just because the power is off, doesn't mean the cap has no power in it. If you're going to start working on home appliances, especially microwaves, use extreme caution. They can and will kill you.
And that's when the grows.
Getting back to soldering the caps. Being that the bases are plastic, this might sound counterintuitive, but I find more heat is the way to go. I usually solder at 700 degrees, freedom units for the win, but with components like this, I boost to around 730, 740. This is more for speed than heat. I find that less heat has more of a chance to melt the base, as it takes longer to get the pad and component hot enough to melt the solder. So more heat, faster soldering time, and a bigger tip helps too. Alright, with those done, let's check the joints. They're looking good, and give the board another good cleaning. The next component that we're doing is a potentiometer. It's called a pot for short. Basically, an adjustable resistor. There is an adjustment dial on the front, and if we go by the code, it's a 10K resistor. So it's adjustable from 0 to 10,000 ohms. It probably controls the speed of the flashing LEDs, but again, no instructions. This is a through-hole part, so it's much easier to solder than SMD components. Just flux and fill the hole with solder. Next up, some jumper pins. Again, no idea what they're for, but super easy to install. Being through-hole components, just place them in the hole, flip the board over. Don't forget your flux. Remember, flux is your friend. And fill the hole with solder, just like the pot. Super easy. Barely an inconvenience. 10 points to whoever understood that reference. The penultimate component, now there's a big word for you, is a patch triode. I thought these were going to be a real pain to solder. They're pretty frickin' tiny, and they have 3 connections to solder. But in the end, they were actually really easy. I also have no idea what they do, so let's hear from Pat again.
A patch triode is a flexible electronic device built using thin films and modern materials, resembling a traditional triode in function. It consists of layers, including organic semiconductors and flexible substrates, with conductive patches acting as the anode, cathode, and control grid. Patch triodes amplify electrical signals and are ideal for applications in wearable devices, flexible displays, and electronic textiles due to their flexibility. They are primarily used in advanced research and emerging technologies.
Thanks for that, Pat. Yeah, I still have no idea what they do. And after looking over the board, they don't even hook up to anything. There's no traces, nothing. They're just there. Well, good practice, I suppose. As always, let's check the joints and hit the board with some more alcohol. And finally, let's put in the LEDs. They're the same as the pot and the pins, through-hole connections. After spending so much time with the SMD components, through-hole stuff seems like child's play. And I guess that's really the point of this kit, because I can tell you, the reveal, not worth the time and the effort. Well, here we are. It's finally done. 2 of the pins we soldered in offer the power. Not that it tells you that, it's just a plus sign and a minus sign next to the pins. If you really don't have a basic understanding of a circuit or diagram, you're SOL. It did come with a battery holder that takes 3 AA's, so there's that. Well, I'm not wasting 3 batteries, so thankfully I have a bench power supply. Another Amazon purchase. $60 American. It actually says in the instructions that it's 4 to 6 volts DC, so let's set this sucker to almost 6 volts and see what it does. And that's what it does. It flashes the LEDs in a chase pattern. Fun times. Oh well, as they say, it's the journey, right? I played with the pot, and that really doesn't affect it that much. If you go all the way to the left, it shuts off all the lights. Once you start getting halfway back, the speed starts to increase, but not much. I played with the pins, and they don't do anything much either. I guess it is marketed as practice board, and as the instructions so eloquently put it, gifts prepared by parents for kids who are interested in. Again, that's a new classic. Well, in the long run, it did give me a lot of practice. I really do like to micro solder, so getting to do a variety of SMD components will just enhance my skill set. You guys got to meet Pat, that's always a plus. Oh yeah, I kinda learned what a patch triode is, and I also get to make a video about it, so there's that. Well, what are you gonna do? I really wasn't expecting it to change the world, but as I said in my rant, just a little more effort from these companies. Better instructions for sure. Hit me up, yo. And they would have an even more fun product. Something, as they said, would be so amazing to share the DIY time and realize your great idea into reality. And with that, I bid you fine folks a hearty bye for now. And please, if you could, subscribe. And as always, thanks for watching.